This is one of the top 10 most important lessons of the second semester. Top 10. There's about 90, in case you keep track, there's about 90-ish days in the second semester. So that puts this in the top 10% of really important stuff. It's not like incredibly hard, it's incredibly foundational. Would you agree that when you learned multiplication back in the day, that it was true that when your teacher said, like, you really need to know how to multiply, like, because that keeps coming up? You know, like 2 times 3 comes up all the time, and you can't afford to look it up on a calculator. You got to know your multiplication facts. Now, the complicated ones, sure, you can get away with not knowing, 144 times 7. Okay. But the basic multiplication, it just keeps coming back. Well, this is triangles and trig, and oh my gosh, like huge. It's huge on the ACT because there's 4 really hard trig problems on the ACT. Pretty much every ACT, there's 4 hard trig questions. Okay, and we're going to cover all of that. And the other reason it's really important is there used to be a class called trig. Like it was the whole year, 1 year long class called trig. Well, it doesn't exist anymore because we pared it down and put it in the second half of pre-calc. Okay, so pre-calc is pretty much half trig. You've reached the trig part. Now you might be like, I already know some trig, sine, cosine, tangent. It's true, but there's actually 6 trig functions, not just 3. And you're going to learn them in the context of like really big angles, like sine of 220. And you have no clue how you'd do that right now, because right now you could only do that if there was a right triangle, which typically means small angles, so less than 90, right? So what we're building to is so important. I'm going to teach you a whole bunch of things that are going to be really, really, really critical. They're going to happen all semester. And some kids will already know them because you were taught these before. And some of you are going to have retained that, and you'll know some of these things. And others of you, you're behind and you need to catch back up. You got to get these things down. So important. All right. So let's talk about these 3 words first. Hypotenuse is always just the longest side. That is pretty simple. But opposite and adjacent depend. They are relative to where the angle is. Right now they're saying this is the key angle. Do you get if I move the key angle up here, then this side is not the adjacent side? Okay, so it's relative to where the angle is. All right, so we're going to stick with looking at that angle down there as our main angle. So from that angle's perspective, this one here is the opposite side, and this one here is the adjacent side. The hypotenuse is just always the longest side, which means it's across from the 90-degree angle. Next there, I want you to understand that if there's an angle that's bigger than the other, then it'll have a side that's bigger than the other. Would you agree that the way this triangle is drawn, these 2 sides do not appear to be exactly the same, do they? That means the angles across from them cannot be exactly the same. The angle across from the side kind of goes with that. So which of these 2 sides looks bigger to you? The blue one or the red one? Which one looks bigger? Blue one. So that means this angle has to be bigger than this angle down here. Do you get that? Okay, bigger angle, bigger side across from it. Okay, and hypotenuse is always just the biggest side because it's across from the biggest of all the angles. The 90. Okay, next, do you agree that the 3 angles in a triangle add up to something? What do they add up to? 180, and that's going to come up over and over again, because if you know 2 of the angles, duh, you could figure out the 3rd one. So that's a critical little piece. All right. Next, there are right angles, and we do a lot of right angles, but then there's other triangles that are not right triangles. But then there's formulas like a squared plus b squared equals c squared, and that works for right triangles, but it doesn't work as soon as it's not a right triangle. So this first chapter, we pretty much stick to right triangles, but then we go to a different chapter to handle the not right triangles. All right. What is this trying to show you? Yeah. See how C has got a big square associated with it? Do you get how this is a squared? And that's b squared equaling c squared. If this was full of water right here, and this was full of water right here, do you get you could pour them in to this, and they would exactly equal it? This full of water plus that full of water poured in there would make that full of water. I've seen a kind of cool demo of that before. All right. A squared plus b squared equals c squared. Yay. All right, so here's something, though, that's really, really powerful that you got to be able to do quickly in your head. You guys remember the 3, 4, 5 triangle? It's the right triangle. It's one of many that are called, not special, sorry. These are called, I didn't use this example last hour, so I'm struggling with the name. Pythagorean triples. There we go. 3, 4, 5 is one of them. There's another couple. Anybody know the one that goes with 5 and 12? Okay, well then you could use a squared plus b squared equals c squared. But I want to show you a way to get this answer way faster. To get this side over here, you start with square root of, please everybody draw that triangle. 5, 12, and we don't know yet, but we'll figure it out. Now, yes, you could write a squared plus b squared equals c squared, and then underneath that put in all the numbers, and then underneath that multiply them all out, and then underneath that combine like terms, and then underneath that subtract something. My point is it takes like 16 steps, and watch how fast the answer could be done. 144 plus 25. There's the answer. That's how big that side is. I can add those in my head pretty quick, can you? Square root of 169, which is 13. So it's the 5, 12, 13 triangle. Do you see how quick it was for me to get that last number? Because I knew it was the square root of something squared plus something squared. All right. If you haven't caught on yet, you can do this on any of the sides. I know the answer is going to be 4 here, but how could I have done it? Well, on the biggest side, we add them. When it's not the biggest side, we subtract them. So it's squareds, right? So 25 minus 9. And guess what happens when you do 25 minus 9? You get 16. And what's the square root of 16? 4. You might be like, well, I'll just always memorize that. 3, 4, 5. Cool. Then what happens when it's not 3, 4, and 5? What happens when this is 6 and this is 4? And I don't know this side. Well, what do? If you haven't learned it yet, you're missing out. Square root of, everybody figure it out. If you watch me do it a few times, you should be able to pick it up. This is going to save you so much time. Yes?
Are we allowed a calculator in this unit?
It's an excellent question. No, there won't be calculators in this next test. So, 6 squared is 36. Always put the biggest one first. Pro tip. There's always going to be two numbers. Usually one is bigger than the other. The only other possibility is that they're the same. But always put the biggest one first. And the other one's 16. And am I on the biggest side here? No, so I don't need the biggest possible answer, which would be to add them, right? So then I use minus. So then that's the square root of, I think it's 20, isn't it? All right, cool. So square root of 20. Next thing you got to know is, oh, can't leave it that way. Do you get that's root 4 times root 5, which is really 2 root 5? That side's 2 root 5. All right, I don't think we're done yet. I think some of you still don't get this. If I said this is 3 and this is 11, is that a possible triangle? Sure, it's just not a perfect one. So it's not one of the ones you memorized, like 5, 12, 13. That's called a Pythagorean triple. But this one, you can figure out that last side super easy. It's the square root of... Nico, what am I going to put where? 121.
Plus 9.
Why'd you add?
Because two sides make the big side.
Okay, the biggest side you need to add the numbers to get the biggest answer. Okay, cool. So that's square root of 130. Could I leave it that way? Yes. I don't think square root of 130 simplifies. I mean, square root of 10 times the square root of 13, but neither one of those works, so I'm pretty sure I could just leave it that way. Maybe if you could figure out that 16 goes into 130 or something, great, but I'm pretty sure it doesn't. All right, so square root of 130. See how fast that was compared to a squared plus b squared equals c squared. Put in the numbers and then solve all the way down and then square root at the end. So much faster. And it even works for stuff like this. X plus 1. What's this last side? Don't say it, write it. Jack, put your phone in phone jail. Your deadly mistake, you smiled while looking down at your hands. Classic mistake. All right, John. How does this work again?
X plus 1 plus X.
You're really close. Remember, it's a squared plus b squared equals c squared. 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 That's the answer. You'll need that later this semester. All right, so that's just a little reminder of how to do a squared plus b squared equals c squared, but way faster. If you know this, you're going to thank me like 10 times this semester, because you won't have to write out a squared plus b squared equals c squared and go through all that work. Yes?
Would you want us to factor it out?
It would be great to simplify it, but we're not going to right now. All right, so one last one. If you really understood this, if this is n and this is 11, what's this side here? Don't say it, write it. And in a moment, I'm going to ask you to compare it with the kid next to you. Yes, it involves an n in your answer. Okay, so write down your answer. And in a moment, people that are straight across from each other in rows 1 and 2, rows 3 and 4, you all have something straight across. And you guys are going to compare first two, second two, third two.
Oh my, so you guys.
Kate, is that filter on right now? This next to you? Press the button in the center. And then press the button closest to you. It's an ionizer. Now you have the cleanest air in the room. Lucky you. It used to be by me up here. I had the cleanest air in the room. And the problem was it was just a little, like makes a little noise. And it makes it really hard to hear the kids in the back. So I'm trying that. Let's try to get a little bit better. All right, so did you get the square root of something? Compare it with the kid next to you and see if you get the same thing. Graham, what'd you guys get?
Square root of n squared minus 121.
N squared. N is the bigger one, for sure, because it's the biggest side. Minus, because this is not the longest side, 11 squared, which is 121. Very nice. Okay, cool. Now, there's a whole bunch of triangles that you need to know, and you need to know sine, cosine, and tangent like the back of your hand. There is a fun little way to remember this, SOHCAHTOA. Raise your hand if you remembered that little saying. Okay, good. So that's sine is, what do you think the O is? Opposite over hype, for stands for what? Hypotenuse. Cosine is ADJ, adjacent over hype. And last is tangent, which is opposite over ADJ. Opposite over adjacent. You guys remember those? So if I start this one, you should be able to do it. I'm not writing sine is opposite over hypotenuse. I'm using this drawing right here and going sine of, well, which angle is important? You can tell because they put this little thing that is a Greek letter called theta. Okay? Sine is opposite over hypotenuse. So what letter over what letter? What's the opposite one from here? A over hypotenuse, C, A over C. Would you please finish what cosine is in terms of A, B, and C? But I want to warn you, it's not like something you should memorize because side A and side B can be reversed. It doesn't matter. C has always got to be the hypotenuse, but A and B, they could be reversed and it could mess you up. So I just don't want you to memorize it this way. Did you get for cosine of this angle would be B over C? And tangent of that angle would be TOA, opposite over adjacent, A over B. You are going to do this so many times, and this is so critical. I'm going to stop for a minute and show you a typical test question where we use this. This is 8, this is 20 degrees, and I want to know how long the hypotenuse is. I'm going to call it h. Would you please write sine of 20, cosine of 20, and tangent of 20? And say what each of them equals. And you might be like, well, I don't even know that one side. Well, then don't do those. The ones that involve this side that we don't have anything for, you don't use those two. Only use the one that uses the 8 and the h. So what is sine? Opposite over hypotenuse. What is the opposite? 8. What is the hypotenuse? H. So that one's 8 over h. Why can't I even do cosine? It wants adjacent over hypotenuse, and there is no adjacent. Like, there's nothing here. So this one's useless. And so is tangent, because tangent is TOA, opposite over adjacent, and we don't have an adjacent. So that one's out too. So only sine made any sense. All right, now I do want to finish this one. Sine equals 8 over h. My number one rule in here is if you can factor it, you should. Do you see any factoring? No. What's my second rule? Clear fractions. Do you see a fraction? Let's clear it. What do we do? Times by h. I'm timesing by h on both sides so that this h will cancel that h. Look at that. Is it solved yet? No. But it's closer because it doesn't have any fractions. Alex, can you help me finish this? We're getting h alone. I'm going to rewrite it. H sine 20. Okay, good. You're going to divide both sides by what?
Sine of 20.
You are correct. Divide by sine of 20. Now, some of you have an instinct to right now, like, go figure out sine of 20 with your calculator. Let's not do that, because you're not going to have calculators in this next test anyways. So then you'd leave the answer like this? Yes, you would. And this is called an exact answer. Do you get if you used a calculator, it'd give you a decimal, which goes on forever and never repeats? So you'd have to round it anyway. So this wouldn't be exact anymore. This is exact. 8 over sine 20. Got it? Okay, let's see if you really got it. Here's a new one. This is M, and this is 14, and this is 18 degrees. Tell me how to figure out M using trig. How do you figure out M using trig? Hint, I'd start with sine of 18, and then I go, does that work? And then I go, oh, maybe it's not that. And then maybe it's cosine of 18. And then maybe it's tangent of 18. It's got to be one of those. So just write an equation that's got sine, cosine, or tangent of 18, and then what it equals. And I'll pause for a second while you compare with the kid next to you. No, just tell me what the equation was. Was it sine, cosine, or tangent? Cosine of 18, tell me the rest. Awesome. And is the M solved yet? No, it's a fraction. We clear the fraction by? And that is what's called an exact answer. It's totally okay. Raise your hand if you had that one right. Okay, cool. So, next thing that's really important here is knowing some certain right triangles. I know that you guys have learned some of the right triangles, like the 3, 4, 5 triangle. Like I'm looking at this one, I'm going, I know that's 3, because you memorized that. But have you memorized the 30, 60, 90 on the 45, 45, 90? Yes.
I have a question.
Yep.
How do you know that it's cosine?
Okay, because it's the, look at the angle and look at how we had adjacent from the angle and hypotenuse of the angle. Let's just look at this one. It's just similar. On this one, if I wanted to find C, everybody take a second and write sine of 25 equals, well, it's something over something. So, Jack, what's opposite now? That's what your problem is you're not knowing which one's the opposite. This is the angle. The one that's opposite is across from it. That's the opposite one. Okay? So the opposite here is B over the hypotenuse, because I know that from SOHCAHTOA, right? So sine is opposite, which is B, over hypotenuse, which is C, B over C. And then that's what I could do on this problem. But the dumb thing is, can you actually solve that? No, so you wouldn't use sine. Henry, what's another one you could write?
Use cosine.
Okay, so let's do cosine, and that, what's that?
That would be cosine of 25 is equal to 8 over c.
8 over C. Could you solve that one? Yeah, you could. You'd times by C on both sides, and then C is getting close to a lone. Divide both sides by cosine 25. And C is equal to 8 over cosine 25.
There's an M.
Then you can solve e.
Oh, 8 meters. That just is meters. Okay. All right. Special right triangles. Remember me saying the 30, 60, 90? Welcome to the 30, 60, 90. But, Mr. Server, there's no 30 there. But can't you, like, use logic to figure out that that has to be 30? Because they add up to 1/8. Okay. Do you know the side ratios? There's 3 numbers. Raise your hand if you're confident you could put the 3 numbers in the right place because you remember them. All right. That is 0 hands that are confident enough to raise their hand right now. I know, maybe. Some people are, maybe. But I'm going to remind you. I want you to scribble out this X right here. And we're going to make the 30-60 triangle classic sides right here. I always pick the smallest side. Can you tell which one's smallest? Well, yeah, it's across from the 30. And it just looks the smallest. That one's always a 1. Why? Well, it's as clean of a number as I can pick. 1's a small number, and it's clean and easy. I could start with a 7 there if I wanted to, but that's not the classic. Classic is 1, 2, and I'd like to tell people it's as easy as 1, 2, 3, but not quite. Because this side is not 3. But what is that side?
4.
Nope, it's not 4 either. Well, what could we do? We could do that square root thing I just taught you. Square root of 2 squared minus 1 squared, which is just 1. So the formula is square root of 3. Oh, that's why Mr. Server says it's as easy as 1, 2, 3. Because it's 1, 2, and the square root of 3. You have to memorize this one. I am telling you, you are going to use this just as much as you use multiply on a typical day of math, where it just comes up over and over. Now you just got to multiply this times this. Do it all the time. Questions?
So if there's no numbers given, could we always start with 1?
If there are no numbers given, then these are the ratios of the sides. But now, in the real world, does that mean every triangle has a side length of 1 right there? No. I mean, I just made it longer by zooming in on it. Now it's longer. Okay, so it's not 1 anymore. But it's the ratio. So if this one's 1, I could say, what if it's actually 11? Well, then I could times this by 11, times this by 11, and times this by 11. See what I mean?
Yeah.
We could scale them all up to be different sizes, but the ratio would stay the same, where this and this are like double each other. And the other one is the square root of 3 times the smaller side. Okay. Now, let's see if you remember the other classic. The other classic is the 45, 45, 90, which this is supposed to be that, but I'm gonna give you that over here. I want you to have a good 30, 60, 90 written somewhere. Hopefully you already did that. I can tell this is the smallest side, so that's the 30, so this is a 1. 2 square root of 3. And the other one that's a classic you have to memorize is 1, 1, and anybody know it? Close. 1, 1, 2 is close. Square root of 2. There it is. Now that's for the 45, 45, 90. You just have to label one of the sides as 45, and you'll be smart enough to know the other one's got to be 45. Okay? And on this one, that's the right angle. And then I know that the smaller one is across from the 1. Smallest side, smallest angle. And I don't have to write 60 because I can assume it. Okay? 30, 60, 90 is 1, 2 square root of 3. 45, 45, 90 is 1, 1 root 2. Okay, now I want to make sure you get the implications of why this is so important. You don't get a calculator for this next test. And there are going to be questions like, what is the sine of 30? How am I supposed to do that without having a calculator? Look at the triangle. Sine is opposite over hypotenuse. So what is the sine of 30? 1 over 2, which is 1/2. I warned you, that one comes up so much. Like literally, I bet you 10 times this year, you'll do the sine of 30. And you'll either have to look it up or just memorize it. Sine of 30 is 1/2. Okay, what's the cosine of 30? Well, here's 30, and here's cosine is a ka. I see I'm going back to that SOHCAHTOA thing over and over again. SOHCAHTOA. Cosine, ka. Cosine of 30 then is what? Rhea, can you shut that door, please? Thank you. Adjacent over hypotenuse, root 3 over 2. Would everybody please tell me what tangent of 30 is? Don't say it, write it. Gotta make sure you get this. So critical. We expect you to just know what the tangent of 30 is, because you have memorized this triangle. On this test, a lot of kids end up writing this at the top of their test. We do not give this to you. You have to memorize this. They're so foundational. It'd be like your address. Do you get this kind of important? If you get lost and you need to get home and you find a nice person and they say, where do you live? I don't know. That would be bad. You lost your cell phone and don't have your mom's phone number. Be honest, how many of you got your mom or dad's phone number memorized? Okay, good. So then you'll be okay. But some of you would be like, you'd be toast. You lost that phone. How would you get hold of them? I don't know. Call my mom. Doesn't work unless it's your phone. Okay, so tangent 30, TOA. Opposite from the A30, that's the opposite, over adjacent, 1 over root 3. Next thing that's really important is that you got to get that there's another way to write this. First of all, did you have 1 over 3? Good. Now there's something called rationalizing. Watch what happens when I do this. I just multiplied by root 3 over root 3. Would you agree that that's like multiplying by 1? And therefore I can do that. Then I get this times this makes the square root of 3 over square root of 9, which happens to be 3. What does that mean? That means this answer and this answer are equal to each other. And you might be like, well, I'm never going to do that because it's harder. You don't have to do that, but what if it's multiple choice? Which they are sometimes in this unit. And this one's in the multiple choice list and the other one isn't. And you're like, well, I don't see 1 over root 3 in the answers. You have to be able to rationalize things. The other one that comes up, of course, is that root 2, because I showed you the root 2 thing. So what if you had a problem that was 1 over root 2? Would you please rationalize that? If you watched me do that 2 seconds ago, you should be able to do this. Jack, you're too warm. Take your jacket off. Take your jacket off. All right. It'll help you warm up. Plus, me talking to you, it'll help you wake up. I mean, not warm up, wake up. All right, Molly, what do?
I don't know.
Okay, you multiply by 2 square roots. Take a guess what that square root is. Square root of 2. All right, you have now learned how to rationalize. That's how you do it. You know why I did that? Because look what's going to happen on the bottom. What's going to happen on the bottom? What's square root of 4? 2. So it's root 2 over 2. The blue one and the red one are equal. You have to understand rationalizing. Do you get I've just taught you like 7 super important, you probably don't know that part, but you have to trust me, super important little things, like how to do sides of a right triangle and how to like get them quick instead of having to do a squared plus b squared equals c squared. I have taught you what SOHCAHTOA does and how we're going to use it. I have taught just so many little things. This unit is so important because all these little things keep coming up over and over again. Somebody sees this on an answer and they're like, I don't know how to do that rationalize thing. Then they're done. They're going to get this one wrong. So how do you do this again? Root 3 over root 3, and then what do you get? And that one's square root of 9, which is 3. Good. You think you could do that? Okay, everybody try 2 root 2, but it's 1 over 2 root 2. What? Well, what are you going to do to rationalize it? John Rafferty, what are we multiplying by on the top and the bottom?
2 square root 2.
Actually, it could be simpler than that.
Square root 2.
Just square root 2. Okay. Top is easy. Square root 2. Bottom, 2 times, what's that? Square root 4, which is?
8.
Hold on. Square root of 4 is? 2. And then you go the 2 times the 2, 4. So the blue one is actually equal to root 2 over 4. That's called rationalizing. Do you get how I got the top was the square root of 2? That's pretty easy, right? And do you get that these two that are circled here, that would be the square root of 4? And what is the square root of 4? 2. And then you times it by 2. That's how you get 4. Okay, so that's rationalizing. So many little things to know. All right, so I want you to zoom in on this problem. If this is a 45, 45, 90 triangle, I strongly recommend that you draw the little classic right triangle that I'm telling you you're supposed to memorize. Draw it next to it in the same orientation. Like don't draw it in a weird way like up here so that the sides aren't matching up nice. Make it look exactly the same as this one. You know the old similar triangles things? I'm making a similar triangle, and it's a 45, 45, 90, so I know it's 1, 1, and what's that last side? Square root 2, good. And first off, do you get that just tells me, look at, these two are the same. So if they asked me this, it'd be a no-brainer. What would that answer be?
11 squared.
11 square root 2, because those got to be the same. That makes sense? Okay. But by drawing it there, if I need to find this side, what's a good letter for this side? C or H. H for hypotenuse, or C because then ABC, C is the longest side. I'm going to go with H this time. If that's going to be H, then watch me show you how to do this without trig. I know, the unit's called trig, but yet you could use trig to do it. But I think this is the faster and better way to go. You set up what's called a proportion. See if you can follow me here. H is to square root of 2. Do you get how they kind of go together? They're both the longest side. H is to square root of 2 as, and this is an old like logic thing that they used to make you do back in elementary school. Do you remember these things? You know, like Robin is to eagle as, and then they give you another couple things, and you got to be like, oh, robins are small, eagles are big, they're both birds. You know, you got to try to like make them like logical. Okay, so anyway, H is to root 2 like 11 root 2 is to 1. Do you see how I set that up? And now I've got an equation, and now I can solve it. But a lot of you are going to kick into middle school mode where you did cross multiply. I think there's a much faster way. And it's called clearing the fractions. Again, that's why I told you it was a big deal. Because it is. Look, I can times by root 2 here, and I'm done. I don't have to do any cross multiply thing. That's gone. H equals 11 times root 2 times root 2. All over 1. Well, what is 11 times root 2 times root 2? Well, it's like 11 times root 4.
22.
22. H equals 22. Okay. Now, what was the process there? I told you to set up a classic right triangle, which most of you had not memorized when you walked in. But hopefully you're seeing it's going to be important. You're going to need to know that one. And you might just think you need to know it for this upcoming test. No, your next like 5 tests, we're going to keep coming back to the 30, 60, 90 and the 45, 45, 90. You've got to memorize those side ratios. Huge. Okay. You draw this, you write in those side ratios, and then you set up a proportion. Let's see if you can do it here. So the first thing is draw a little triangle in the same orientation as that one. But this isn't the 45, 45, 90. What's this one? Say it if you know it. 30, 60, 90. Good. And that means I said it was as easy or almost as easy as 1, 2, 3. Because it's 1, 2 on the bigger side, square root 3 on the last side. Okay. And which side do we want? Well, they never actually said. So I can figure out any side I want. I personally am going to have us figure out H. So, pro tip. Yes, you can do this is to this, like that is to that. I think most of you got that idea. But always, I only learned this after doing this for a couple of years. If you always start with the variable, you save yourself a step every time. Because yes, I could say 2 is to H, but then the H is on the bottom and it's much more complicated. So just always start with your variable. You want to solve for the variable, right? And then your variable will be on the top, which makes it easier. H is to 2 like 10 is to 1. And then you just got to clear the fractions. Don't cross multiply. Clear the fractions. Do you get just kind of times by 2 on both sides? H is 20. Raise your hand if you had H is 20. Okay, cool. All right, let's see if that really stuck. Imagine, fast forward to the test on this unit. You've got a 30, 60, 90 triangle. This is the 60. I can tell because it's across, well, the shortest side is here, and so that has to be the 30. All right, so that's the 30, 60, 90 triangle. And they're giving me this side is the square root of 17. And they want to know this, and they're calling it A. Now, there's two ways you could go. You could write a trig equation for this. The problem with that is, at the end, you're not going to have the answer as easy because it's going to have like sine, cosine, or tangent in it. So what if you don't want to have to actually use trig? Then you can make the little classic 30, 60, 90. You put in the numbers here, here, and here. Set up the proportion. This is to this. And what do you always start with if you're setting up the proportion? The variable. You should be able to figure out what goes in those 3 dots. Then you should be able to set up the proportion. And then you should be able to solve the proportion. I'm going to pause for a second. Let me give this a shot. Okay. Did you get that this was a 30, 60, 90, and thus a 1, 2, square root 3? Who put their numbers in the right spots? That's key. Next thing is, start with A. A is to root 3, like root 17 is to 2. You gotta keep them in the right order. You can't reverse that. And then, clear the fraction. Don't cross multiply. Boom. A is root 17 times root 3 all over 2. Can I leave it like that? Yep, you could. Do you think I'd expect you to know what the root 17 is? No. Could I put root 17 and 3 together? Well, if I can do 3 times 17, let me check. 30, 21, square root of 51. That'd be okay, too. All right. Now, here's ones I would do for practice if I were you. On this page, crucial for you to scribble out number 7 because it's screwed up. This is a 30, 60, 90 triangle, and they have a 45, and that's supposed to be degrees, but it's not, and it's so messed up. So scribble out number 7. That problem is messed up. You know, I usually say, well, you can do them if you want. Don't do that one. It'll just mess with your head. Because they drew a 30, 60, 90 triangle, and they labeled it as a 45-degree angle. And so messed up. This one is a problem. Do you get that they have given you A, and they've given you B, big B, and they've given you big C? Clearly, it's a 30, 60, 90 triangle. I just showed you how to do that. You draw the little helper triangle next to it, it's what I call it. In the same orientation, 30, 60, 90. I'd set up a proportion to do it. That's how I'd do it. Could you do the tangent of 30 is opposite over adjacent? Sure, that way works too. All right, problem 5 I would strongly recommend. Problem 9 I would also recommend. These are the meat of today's thing. You got to be able to set up either trig equations or those little proportions I just taught you. And there's only one more that I would recommend. And it's not on this page, so cross those off. This one. It's a good, clean, simple problem, but makes you think. That's typical of our tests. They're kind of like this one, so I'd do this one. And I think if you just do those 3 questions, you'd be in good shape. That's all I got for you for today.